take you through one of the SCE categorization. This is one of the most beautiful one I have seen in the industry. And this is the one I actually, saw with one of my clients in Calgary, Alberta here. Now, if you are a student of bow tie, you know that the unwanted event is always the hazard, whether it's the failure of a valve, whether it's the failure of a mechanical systems, or whether it's electrical power failure, or whether it's the failure of a pump or a compressor station, which we always call the hazard. If you have a hazard leading to a consequence, especially consequences that are major or they are severe, if your barriers align and they do not actually protect you from that unwanted event, you're going to have either a fire, you're going to have an explosion, you can have an overpressure, it can be missiles flying around everywhere, and you can actually have, at the end of the day, release of toxic chemicals. Now, how many people know in the industry that if you design a vessel that is above 15 psid, a vessel that is called pressure vessel, how do you know it is critical? And what this organization has done is that they've been able to actually look at, from the design to the commissioning to the operation and to the decommission of the plant, they've been able to align and actually give their SCEs, or safety critical element, different category. The first group they did was structural integrity. If you are a student of process engineer, or other forms of engineer, you will notice that the moment you design anything, the structural integrity, whether it's the vessel that is standing on the structure, or whether it's the piping system on the pipe rack itself, things like subsea jacket, offshore, the vessel hull, the top side, the crane, the heavy lift cranes, equipment, stability system, and the vehicle and mobile plant. People even forget that vehicles actually are part of the safety critical equipment or element in the industry. Because if those vehicles go into an area where the hazard is there and they're not supposed to be there, that can lead to an unsafe days. So the first one is the structural integrity. If you get the structural integrity right from design, the next one you want to do is the process containment. The process containment in itself, example of that process containment are pressure vessels. Pressure vessels are designated prescriptive as SCE by code and standard. In Alberta, the Alberta Boiler Safety Association, in BC, Technical Safety BC. In the US, everybody has their jurisdiction. In the UK, control of major accident hazard through the PSSR, pressure safety equipment regulation in the UK, which gives you the prescriptive nature of what a pressure vessel will be. So things like pressure vessels, heat exchanger, rotating equipment, tanks that contains flammable toxic fluid, piping system, onshore, offshore system, PSV, which is the pressure relief system, well hydrocarbon containment, and a whole lot of all these things. These are process containment. Once your process can be contained, the next one you want to ensure is that the ignition control. How many people know that the hazardous area ventilation is actually an SCE? A lot of people fail to understand why we have to make sure that when we design an HVAC system, are we designing it for the right service? And when we do a QRA, quantitative risk assessment, we know what is the functionality of those things. So we have things that are called ignition control system. And what this does for SCE is that if you can control your ignition, you are sure you can be safer than yesterday, and there won't be an explosion on the plant or a fire. The next one are the detention systems. This one, most of the time, they are mitigative systems. Example of this is the fire and gas system. And from there, we go to the protection systems. The protection system, we do have some that are mitigative. We have some that are preventative. And there's a list of protection systems that you can see as SCEs. The one a lot of people know about in the industry is mostly the shutdown system. The shutdown system mostly are the ESD system, the emergency depressurization system. If you have a fire and you have an unsafe situation where you can depressurize the system, the HIPS, high integrity protection systems. Some organizations have it, some don't have it. Some would think an HIPS is an SIS system. Two different systems, but similarity in function if it's pressure they are trying to regulate. And the last part of it is the instrument, air, and gas system. Again, a lot of people don't know that the instrument air system is also an SCE. And why is that? Why is that an SCE? If it's the instrument air that is feeding your valve, If your valve is supposed to malfunction close and it doesn't close when you need it to function, that becomes a bigger problem for you at the end of the day. And the last two are the most underrated in the industry. If you look at the issue of the Texas, US issue, the Bunksville disaster, and you look at the Caribbean Petroleum Company, CAPECO, the issue they had in the industry, it is the emergency response that always fails. Again, if you do process hazard analysis, you find out that a lot of people don't take credit for emergency response plan, mainly because we don't know if it's been adequately designed, or if you have, on the day you have an unsafe days, you can have the emergency response people show up on time. So on the plant, things like the muster area, do you know where your muster area is? Are they adequately designated? Are they reflected on the plot plan? All these are questions you have to ask whenever you go to a site. Sometimes when we do audit, the muster area is one area we actually look for to ensure that everybody know where the muster area is. And the last one is the life-saving system. From the life savings, you will know they are mostly the PPE, personal protective equipment, and the last one, personal survival equipment, like SCBA. If you don't have an SCBA in an H2S environment, and there's a release of H2S, definitely that's going to lead to a major accident hazard. Do you know what your safety critical elements are? Or do you know what are your safety critical equipment? They properly designed? When last were they tested? Can you show me? Show and tell is one of the reasons why our industry can stay safer than yesterday.